Let's talk about the factory design pattern. This is one of the most used design patterns. It represents well the principle of program to an interface, not an implementation. It decouples the construction of objects from the objects themselves and replaces the regular class constructor. Remember, loose coupling is a goal in best coding practices, so this is a win. This is useful when you have multiple classes that share a common superclass. By applying the factory design pattern, we add an extra layer of abstraction, and the client function can make a call for any of the subclasses without needing to be aware of which subclass is needed in each situation. This way, the class instantiation is delayed until runtime. It may be easier to understand the factory design pattern when looking at an example. Let's say we have a very simple program that draws some shapes on the screen. In order to do that, it uses three different concrete classes: circle, square, and rectangle, each with their own draw function. These concrete classes all implement the shape interface. From here, what the factory design pattern does is basically go up one more level of abstraction. An important difference here is that the client function doesn't need to have the exact subclass hard-coded, as it can even be passed as an argument, as we can see in the simplified Java example. Here we instantiate the factory, and then we use the factory to dynamically create a certain shape at runtime, in this case a circle. Notice that the subclass is specified in the argument. And then we just draw the shape. For our homework scheduling program, let's say that we need to populate a daily summary to be displayed to the user. The items in this list could include homework assignments, calendar events, reminders, and announcements. Each of these types of list items would have graphically representations in slightly different ways, and we could decide to make each type its own class and leave it at that. Or we can go up one step further and make them implement a common interface list item. And then we can use the factory design pattern to make our code more loosely coupled and manageable in the future by creating a list item factory. Just like with the shape drawing program, the client function won't need to have each class hard-coded, making the code more flexible.
Awesome. Great job at explaining the factory design pattern. Now let's talk about some of the pros of this pattern. It allows for more flexibility and allows for objects to be created with a method rather than always having to use uses. Now, for me, that's a huge thing. In my other coding classes, always having to use uses gets really annoying really quick. So, factory design pattern, it eliminates that need. It is also one of the most frequently used design patterns. This is important because as a coder, you will be working on a team at some point in time, if not constantly. Therefore, other people are going to be looking at your code, and if someone else is looking at your code and tweaking it or changing it, whether it be a manager, a teammate, whomever, if you're using a pattern that is commonly used and commonly understood, it's going to be much easier and much better for your entire team. It also allows for object creation and encapsulation within a separate method. So this allows for the instantiation independently from the class via subclasses. So in my example over here, you can see that both the toy duck mold and the toy car mold use the injection mold. So we could call the toy factory and ask it to do toy duck mold. Well, toy duck mold automatically knows that it needs to do an injection mold. So it automatically goes to that. We don't have to say, call toy duck mold, which uses the injection mold. Now we're going to talk about some of the not so great stuff or some of the cons. So some of the cons is that factory design patterns can be very complicated for newbies. I say very as a very loose term. So when you are working with code for the first time, understanding the fact that you're making a factory and that the subclasses are not talking to the parent class directly can get really confusing really fast. Uses prevents that, but uses makes it more complicated, and it makes it more highly attached and highly coupled, which we don't want. We want it loosely coupled. Another downside is that it can lead to the creation of spaghetti code, because when people are coming in and looking at your code, they're not always going to understand that the toy factory is creating a duck, but why does the duck not have to use the inject mold? So some people would consider that to be spaghetti code, and it gets really complicated really fast. Also, it can lead to unnecessary complexity of the application. So you're trying to figure out how to do this superclass and how to get the subclass, and it can get super complicated super fast. And Yoda's here to remind us that the lack of a design leads to spaghetti code. Spaghetti code leads to suffering. Obviously, with using factory design, we're not leaving out design. We just have to know how to use it correctly. Now let's talk about when we should use it. Factory design is best used when you need a factory. So we'll go back to the toys for a second. We need a factory because either toy uses the inject mold, but if we simply say, hey, toy factory, call duck mold, the duck automatically knows that it needs to use the injection. I have another example up here where we have logistics, and they're trying to determine the transportation of goods either by road or by sea. Now, by understanding this, we can create transport, and we can tell it the road logistics can create a new truck, or the sea logistics can create a new ship, and we don't always have to say using logistics. Makes it kind of nice. So another example would be an animal class. An animal class could be instantiated by mammal, reptile, or bird. So you don't always have to be mammal is an animal. Reptile is a bird. Or reptile is an animal. Bird is an animal. It can also be instantiated in such a situation where you might have a vehicle factory, but you want to be able to make cars, buses, motorcycles, and trucks. You don't always want to have to say, the car is a vehicle. You get my point. Really, it comes down to this one question. Do you have a superclass that could have or would have multiple subclasses? If you do, this might be a great time to use factory design.